All right, so this will be use Pythagorean Theorem to find distance of a segment. Okay, this will replace the distance formula. So before we get to the actual problems, let's go over the steps. You want to construct a right triangle using vertical and horizontal segments. The original segment, in other words, the segment you're finding the distance of, the original segment should be the hypotenuse. That'll be across from the right angle. Okay, you want to use a squared plus b squared equals c squared and solve for c squared. The lengths of the horizontal and vertical lines are a and b. So they are going to get plugged into the formula here for a and b, and you're going to solve for c squared. And then, of course, solve for c by taking the square root. All right, so let's say you have a segment on the graph. What you want to do is construct a vertical and horizontal line. Okay, so here is a vertical line, and here is a horizontal line. Okay, and those two segments are going to make a right angle. Now, it doesn't matter which side of the line segment you're on. If you did the segments on this side, it would have been the same thing as if you did it on this side. The main idea is that the right angle is going to be pointing at the original line segment. Okay, so the original line segment is going to be across from your right angle. That's going to be your C, or the hypotenuse. All right, I'll just abbreviate hypotenuse. So that line segment is always going to be the value for C. A and B is going to be the lengths of the horizontal and vertical lines. A and B are interchangeable. It doesn't matter which is which, as long as your hypotenuse is C, across from the right angle. All right, so I'm using the distance formula CUDA software worksheet for my examples. They want us to find the distance. So let's find the distance of this line segment here. Like I said, we're going to be using a squared plus b squared equals c squared. Now, you can certainly obtain the coordinates of this point and use the distance formula, but that's not the idea behind this exercise. We want to find, we want to do it with the Pythagorean theorem. So again, you can work on either side of this line as long as you construct a horizontal and vertical line. So I'm going to do that right now. All right, so for the vertical line, we just draw that right here and go far enough down to reach the other point. And then the horizontal line, just connect that other point. And now we have a right triangle. Okay, of course, the right angle is right here. And the line segment that we're finding the length of, that needs to be across from the hypotenuse. Across from the right angle. Okay, so this side length is C. Okay, C is always your hypotenuse across from the right angle. The other two sides, it doesn't matter which is which. A and B are interchangeable. So I'll call the vertical one A. I will call the horizontal one B. All right, so we're trying to find the length of C, the hypotenuse. That's the original line segment. Let's count the length of the other ones. Right here we have 1, 2, 3, 4, 5, 6, 7. Okay, so A equals 7. And counting for B, 1, 2, 3, 4, 5, 6. Okay, B equals 6. So we have the equation here for A squared. A is 7, so A squared is going to be 7 squared. For B squared, B is 6, so B squared is going to be 6 squared. And that equals C squared. Now, some of you may take the square root of both sides at this point. That's perfectly fine. I'm going to write out the rest of it just in case people need it. But you could take the square root of both sides right here in this step. 7 times 7 is 49. 6 times 6 is 36. And that equals c squared. 36 plus 49 is going to be 85. And that equals c squared. And the opposite of squaring something, the way to undo something squared is to take the square root. All right, you want to do square root on both sides. Square root of c squared is just c. Square root of 85 we're going to do on the calculator. All right, square root of 85. Close parentheses, hit equals. And they said round to the nearest tenth. So you look at the second decimal. If it's less than 5, you round it down, so it's just 9.2. If it's 5 or more, you round it up, and it would have been 9.3. But here you round it down, 9.2. So that's it. C is 9.2, and you can just check your answers on pages 3 and 4. All right, please pause and try number 16. All right, so we have the original line segment right here. Construct a right triangle around that. The other one I did on the bottom. This one I'll do it on the top just to prove it to you that it works. Okay, so we're going to make a horizontal line. That's a little crooked here. We're going to make a horizontal line and a vertical line. Okay, and as you can see right here is the right angle. Okay, that right angle should be across from the line segment that you're finding the length of. It should be across from it. And just make sure, once again, that these squares count by 1. Okay, make sure they don't count by 2. This is 2 right here, so this is 1. This is 3. So, yes, each square is worth 1. Okay, so this length right here is going to be 1. And the horizontal is going to be 1, 2, 3, 4, 5. Okay, that's a 5. All right. So as always, we're using the Pythagorean Theorem. A squared plus b squared equals c squared. A and b, it does not matter which is which. So I will let 1 equal A. And I will let this length here of 5 equal B. And the one across from my right angle, the one I'm finding the length of, has to be C. All right, that's the unknown value. In place of A squared, in place of A, I'm going to put 1, so A squared is going to be 1 squared. In place of B, I'm going to put 5, so B squared is 5 squared. And that equals C squared. Okay. Now, again, you could multiply and add these out. But really, at this point right here, you can take the square root and find the answer. Okay. The opposite of squaring something is square root. And this will also be square root. You want to do the same thing to both sides. Bring down the equal sign. Square root of C squared is just C. And I'm going to do the square root of 1 squared plus 5 squared on the calculator. All right, so square root of 1. Let me see. All right, this calculator doesn't have a squared, but it has the exponent button. So 1 squared, close parentheses, plus 5 squared, close parentheses, and then close them again. Square root of 1 squared plus 5 squared. Hit equals. And again, 1 decimal, so you look at the second decimal. If it's 5 or more, you round it up. So 5.0 is going to be 5.1. All right, so the length of the line is just 5.1. For the ones that are perfectly horizontal or perfectly vertical, all you have to do is count. Okay, like I said, make sure that each square is only worth 1. And then you can just count this. All right, just go 1, 2, 3, 4, 5, 6, and that's it. The length of that line is just 6. If by any chance it was really too long to count, then just look at the x or y coordinates, okay? In this case, you would just ignore the x coordinate because the x coordinate is -4 throughout. But if you look at the y coordinates, we have a 2 and we have a -4. So it would just be the absolute value of y1 minus y2. Okay, and that would just be the absolute value of 2 minus -4. Two negatives in a row make it positive. And 2 plus 4, of course, is 6. And the absolute value of 6 is still 6. All right. This worksheet, there's nothing real long lines here. But if there was a real long line, instead of counting, you can just subtract the coordinates and take the absolute value. Okay, it also works if the line was perfectly horizontal. You would do the same thing, except you would get the points or the coordinates from the x-axis instead.